Welcome back, my Algebra 2 students. We are in lesson 72, and we are going to talk about lines from experimental data and negative angles. Okay, so sometimes the lines from experimental data aren't always in a straight line. They're not easy to find. And up until now, the book has been drawing the line for us. But now, joy of joys, you get to draw your own line and figure it out. And for that reason, along with the fact that it's never exact anyway, you will not always get an answer that matches what is in the book. So what I'm probably going to do for these types of problems from this point forward is give you a multiple choice answer, just because you're never going to be able to match it exactly right. But if you solve it, you should be able to get close if given a multiple choice, and then you can still get the answer right by figuring it out. But we're going to go ahead and try to do this one on our own. But you're going to have to try to draw your own line and get close. And then if you can get the right multiple choice, then you know you did it correctly. Okay, so there is never, according to the book, an exact answer to these problems. The points are often scattered, and we can only estimate the position of the line. So we're going to draw two lines. So we're going to draw one, right about like this. I'm going to let it straighten itself out. Okay. All right, so it's through the first point and it's through the bottom point. So that's actually pretty close. I do like that. But I think I like it even better if it's through that point, 40. And I'm going to put it right in between these 2 points so they're all kind of touching. And that's right halfway of this one. I'm going to call it halfway. All right, so that works. All right, but now I need to draw another line for here, right? So let's do that. We're going to draw another line. I'm going to let it correct. There we go. And I'm going to try to get it right on that same point at the bottom. And let's see if I can get it close. Okay, those are both touching. And it's touching the pink in all of those lines. And I'm going to get it right on top of this line just to make it easier to calculate. All right, so it's touching the pink. It's going right through the center of that one and touching the pink here and touching the pink here. And that's our error of margin. So I think I've got some good placement for these points. So let's see if we can solve these two. Okay, so it appears that line A is passing through on the x-axis, the first line. Let's call this A. Get my pen back, and we'll call this B. Line A is going through 0, 40, and 0. Okay, on one end. And on the other end, it looks like it's going through, this is 120.5. And 10. Okay, and I'm really close to what the book has said. So that's good. That's fine. All right, and this one, this is line A. Line B looks like it started at 40 and 0 also, and it ended up at, this looks like 180 and 10. All right, so those are my two lines. So the first thing I need to do is I need to write my my linear equation for this line. So I'm going to have to figure out the y-intercept given one of these 2 points later on. But right now I'm going to do the slope. So it is going to be salt. The symbol for salt is S. The symbol for carbon is C. So it's going to be, since S is my y-axis, it's going to be that S is equal to the slope of carbon plus B. And that's going to be for both of those. Salt is equal to the slope of carbon plus B. So now I just need to figure out what the slope of A is. The slope of A is going to be y over x, the change in y over the change in x. So my y points are 0, minus 10, and I have, actually, you know what? I'm not going to do that. I'm going to do this. I'm going to take the bigger one and do it first. 10 minus 0 and 120.5 minus 40, because why do that to myself? Sorry, so it's 10 over, that'll be 80.5. All right. So my slope is going to be, let's see, all right, it's going to be 10 divided by 80.5, 0.124, we'll stop there. So my slope, M, is equal to 0.124. All right, so we can do this. S is equal to 0.124 carbon plus B. Now I just sub in one of those points for S and C. And since S is in my Y position, this is going to be 0. And this is 0.124 times 40, because those are the same points. That lets me solve for B, right? So I do this. I say what was it? Oh goodness, 10 divided by 80.5, 124, okay. All right, so 0.124 times 40 equals 4.96, and that's going to be a negative. So negative 4.96 is equal to B. Because it was over here, I had to subtract it to get it over here so I could solve for B. That's why it's negative. So now I can write my line. S is equal to 0.124 carbon minus 4.96. Why is it negative, Miss Tracy? Because this line right here, A, is going to keep going down and down and down and down until it crosses the y-axis here. This is below the 0, so that's going to be a negative 4.96. This actually is going to cross right about here somewhere, because that would be almost negative 5, right? So that's about where that line would cross, and if we extended it, that's about where it would hit. That's about right. My prediction is that this slope is different, and it's going to hit closer to the 3. So I'm going to put a little mark here. This is where this one is. I'm going to put a little mark here. That's my guess for B. This is A, and this is B. This is where the slope intercept is for those. So let's try B. So for B, we're going to do the same thing. We're going to do the change in y over the change in x. So 10 minus 0, 180 minus 40. Okay, 10 and 180, 0 and 40. So that's 10 over 140 equals, let me get up my calculator, 10 divided by 140. My slope is 0.0714. I stopped there because the next number is smaller. That's always a good stopping point when you're doing decimals, is keep going till you either hit a 0 or until you hit a number that's smaller than the last one you were at. Technically, we could stop at 0.07, so why don't we do that? 0.07. So M is 0.07. So S is equal to 0.07 carbon plus B. So now we sub in this point. This is 0 for salt. 0.07 times 40 plus B. So now I just multiply 0.07 times 40. I get 2.8. And I'm going to swing it to the side so that I solve for B. So it's going to be a negative 2.8 is equal to B. So now I can write it out again. S is equal to 0.07 carbon minus 2.8. And what did I say? I guessed that it would be right about 3, and 2.8 is right about here. So it was almost 3. So just following the line, I was able to get a good guess on where my y-intercept point was. So that's pretty good. So the numbers, having that guesstimation on the front end, makes me feel confident about my answer. So that's not a bad thing to do if you're in that situation, is to give yourself a good guess, see where you think it should be, and then when you get close, you feel more confident about it. If your answer is way off, then you know you did something wrong. Like if my answer was a positive 2.8, that would be up here. That'd be way off. So I would look back and I would say, oh, well, I forgot my sign. My sign is wrong, or something like that. Okay, so those are the answers for this one problem. We have 2 lines that are possibly correct. All right, that's all we have for 72 point A. Let's talk about 72 point B. And we are going to, oh goodness. There we go. Let's scroll up and get some white space up here. Okay, so far in doing our vectors, actually, we probably need to come down here for vectors. I don't know what I was thinking. All right, let me clear this. All right, I'm clearing this. All right, so when we do vectors, so far, up to this point, we've only done positive angles, right? And by that, I mean we've done like these types of angles, you know, but they've always been positive. And that's because we would start here and go counterclockwise. We'd go through quadrant 1, quadrant 2. All right, so that was 90 degrees, 180 degrees, 270, back to 360. What if this is negative? What is your first guess on what that would mean if this is a negative degree? If this is a negative degree right here, it just means we go the opposite direction when we calculate. Another thing about that is that if let's say I have a 45 degree angle, let's say it's 6, I'm going to erase that. Let's say it's 6, a vector of 6 length at a 45 degree angle, which would put it right about here, right? That's measuring from here to here. That's 45 degrees. If I measured it all the way around the other direction, what do you think that would be? That'd be 6. And it would be 90, 180, 270, plus a negative 45, or negative 270. So that'd be 315. It'd be a negative 315. Why is it a negative 315? Because all the way around would be negative 360. Okay? So negative 360 plus 45, stopping 45 short, is equal to negative 315. So when you measure from this direction around, it's just a negative degree. Whatever is in here, you add it to negative 360, and you get the opposite. So this equals this. They are the same point. They are exactly the same point. It's just the direction that you measure them from. So from here to here is positive, and from here around backwards is negative. But it's the same position, the same length. So it is the same point. It just depends on which way you go. Now, why do they have positive and negative on this? Because, my dears, why would you want to measure all the way around to get to here when you could just say this was a negative 45? Right? Think about that. So a positive 315 means you have to go all the way around to here, when you could just say it's a negative 45 and it's understood that it comes from here to here. And there's less math to do. And when you're talking about air traffic controller, I think the faster way is better. They need to know quicker, right? Okay. So that is the difference, and that is the reason there is a difference, is because it's just easier to memorize. So once you go past the 180 mark in either direction, typically they flip it, right? So you typically don't see anything past positive 180 or less than negative 180. Once it gets to that point, then they just measure from the other side. Okay? Does that make sense? Is that understood? It's like if you're trying to go around the house to meet your friend. If your friend is standing here, you're not going to go all the way around to meet your friend. You're just going to go to the other side. Right? So that's what they do. Instead of going all the way around, they go the short way. The short way is better. Okay. So let's do a problem, 72.2. I'm going to clear this because I think you guys get the idea. You guys are very, very smart. So we're going to write this for, and it is negative 210. And they did just exactly what I said they don't typically do in the real world, but they're just trying to teach the point. So forgive Saxon for their faux pas. Faux pas is French for false step, and it just means a mistake. So we're going to draw our own little coordinate system here. Okay. So we always measure the angle first. So if this is 90 and this is 180, right? 210 minus 180 is going to be a 30-degree angle. So it's going to be about right there. Okay, so that's 30. And then we are going to draw our length. Not exactly sure about how long. We'll just draw it right here. It doesn't have to be exact. It just has to be close. Right? This is 4 right here. That is our hypotenuse right there. It's always the hypotenuse. So we are going to find the this would be the U, and this would be the R, right? And this would be a negative R, while this would be a positive U, because this actually goes up, but this goes to the left. All right. Now the other thing that's kind of cool is that we know that these are the same when we write this versus the polar coordinates, but the book is now teaching us to write that they are equal in a straight line, which is kind of cool too. Okay, so if we take the sine of U here, or actually the sine of 30, to find the U, we get u over 4. When we multiply that, we get the sine of, I'm going to go underneath. The book has it to the right, but I'm going to go underneath. So the sine of 30 times 4 is going to equal u. And we got here because we said 4 times this, those canceled. And then we did 4 times this because we had to keep it equal. So we have 4 times the sine of 30 equals u. So we pull up our calculator and we say 30 sine times 4 is 2. So 2 is u. So that's going to be positive 2u, right? There we go. So now we're going to do the cosine of 30 to find r. Okay, so the cosine of 30 is equal to r over 4, and it's going to be a negative r over 4. So we multiply everything times 4, both sides, so that's 4 times the cosine of 30 equals negative r, right? So let's pull that up. Clear 30 cosine, oh goodness, times 4, 3.464. We'll stop at 6 because this is a smaller number. So 3.464. 3.46 is negative r. We don't like to have this negative, so we transfer the negative over here by multiplying everything times the negative 1. So negative 3.46 equals r. So negative 3.46 r plus 2u. And that is how we would get there. Okay, the only thing we did different was we measured from here around to get our 210. The other way that we could have written this would have been 4, and this would be 90, and this would be another 60. So that'd be 150, right? 150 degrees equals negative 3.46 r plus 2u. Because see, even though this might change, negative and positive, based on the way that we measure it, this doesn't change. This stays the same because it's relative to the origin wherever it is. It's not relative to a direction. It doesn't matter which way you came. It's relative to this x-axis and the origin. So there is no flipping it when you come to your polar coordinates. Or I should say your rectangular coordinates. This is your polar coordinates. All right, so I hope you guys see that. And let's see, do we have another one to do? Nope, that's it. We are done. That is all of lesson 72. Excuse me. I will see you guys in lesson 73. If you have any questions, let me know.